certification film for the Wills Wing 167 Sport. The first requirement is to demonstrate that the glider can be launched from a slope not steeper than 5 to 1 in a wind of not more than 5 miles an hour. The yarn telltale on the front wire shows the wind to be negligible, and an electronic angle finder mounted on the slope, not shown in this condensed film, shows the slope to be 8 to 1 in this case. This section of footage is designed to show that the glider behaves normally under normal flying conditions. The pilot does a series of maneuvers, including turns, slips, mild dives, reversals, mild stalls, etc., designed to show that the glider will behave as expected in response to normal pilot control inputs. Review board members viewing this section of the film are looking for evidence that the glider is stable in all 3 axes: pitch, roll, and yaw. In addition, they look for the glider to recover to a normal flight attitude if it's momentarily stalled or slipped during a turn, without the requirement for any excessive or extraordinary skill on the part of the pilot. This section requires that the pilot perform a circling turn of 15 to 20 degrees bank, and that the film show that the pilot remains at the center or below the center of the bar during this maneuver. This is designed to show that the glider has adequate spiral stability and will not exhibit an uncontrollable tendency to roll into a steeper and steeper turn. Next, the pilot performs several stalls. First, a stall in a turn to show that the glider recovers from a stall without any uncontrolled tendency to roll steeper into the turn or to drop into an uncontrolled spin. And secondly, a stall performed while flying straight ahead and wings level. The requirement here is that the glider must recover from the straight ahead stall without rolling or yawing more than 15 degrees from its original heading. Beyond that, it's required that the glider not show any tendency to snap into a spin if stalled while flying straight ahead. The pilot must make an honest attempt to spin the glider. This is usually done by going upright in one's harness, putting one's hands on the uprights, and pushing out and over on the bar to the high side of the bar during a moderately banked turn. The Sport is a difficult glider to spin and will recover from a spin once all control pressures are relaxed without loss of excessive altitude. Spinning, however, is not a recommended maneuver. There have been known cases of gliders becoming inverted during recovery from aggravated spins and suffering structural failures. The 45 to 45 roll reversal test is a requirement designed to show the degree of the glider's lateral controllability. The pilot executes a 45-degree bank turn in one direction, making one full 360 and then reversing on heading, performing a second full 360 in the other direction, and reversing on heading a second time. The time from the pilot's first movement to initiate the reversal until the glider attains 45 degrees bank in the other direction must be less than 4 seconds for a pilot at the minimum recommended wing loading. The pilot is required to perform a dive in which the glider makes an angle of at least 75 degrees nose down with the horizon. During this maneuver, the airspeed is recorded and included in the report. In the case of the 167 Sport, the maximum airspeed attained was approximately 65 miles an hour. Finally, the pilot executes a landing, demonstrating that the glider can be landed without the use of extraordinary skill or without any undue difficulty. There are three requirements that must be demonstrated using onboard film footage. First, that the glider can be accelerated from stall speed to faster than 30 miles an hour in less than 4 seconds. Second, that the glider can attain a minimum speed of at least 35 miles an hour with the pilot pulled all the way in. And third, that the glider is stable, that it has a stable trim point and tends to return to that trim speed from any speed within the speed range. The mirror above the airspeed indicator shows the pilot's hands relative to the control bar. The pilot, first with open palms against the front of the bar, pulls all the way in, causing the glider to accelerate rapidly to faster than 35 miles an hour. This takes care of two of the three requirements in one maneuver, that the glider can accelerate within 4 seconds and that its maximum speed is 35 miles an hour or greater. It also takes care of a part of the third requirement, with the open palm showing that the glider is stable and that the bar does not tend to move in to a faster speed. The pilot then performs this same maneuver for several other speeds within the speed range, each time applying open palms to the front of the bar when accelerating to speeds faster than trim, or behind the bar when slowing down to speeds below trim. In each case, the open palms show that the bar is pushing back against the pilot in a stable manner, and in each case, when the pilot relaxes the pressure, the glider returns to its normal trim speed. On the vehicle, 3 structural tests are required. The first is a negative 30-degree angle of attack test. The glider is mounted nose down with the keel at 30 degrees below the horizon. The required ultimate speed for this test is 46 miles an hour, and the glider must hold it for 3 seconds without structural failure. The white tape on the face of the meter dial is placed at 46 miles an hour, so that when the needle disappears behind the tape, right now, the glider is going 46 miles an hour, the maximum required speed. There is a requirement that no deformation or bending, permanent bending of the structure, be shown at limit load speeds, which are in each case 80% of the required ultimate speed. However, with the 167 Sport, we were able to show no permanent deformation of any structural member following the ultimate test speeds. The frame that was used in each one of these structural tests was later assembled onto a demo glider and is still being flown today. In this sequence, the designers are varying the angle of attack and using the tufts to determine at which angle of attack the root section stalls. When the tufts blow forward, the wing is stalled. The glider is then mounted at the stall angle of attack for the positive load test. The required ultimate speed in the positive load test is 65 miles an hour. And again, that speed must be held for 3 seconds. A watch is filmed in order to calibrate the running speed of the movie camera and movie projector. Once again, a piece of tape is placed at the required ultimate test speed, in this case 65 miles an hour, at a position of about 1 o'clock on the dial. The image of the glider in the mirror is used to show that no structural failure occurs to the glider during the test. The load vehicle has now attained a speed of 65 miles an hour as the needle disappears behind the tape, and then as the needle reappears on the right-hand side, the maximum speed in this test of 70 miles an hour is achieved, 5 miles an hour faster than the required ultimate test speed. Following the test, film footage of the glider is taken once again to show that there's been no permanent deformation of any of the structural frame members of the glider. The final load test is the negative 150 load test, the most difficult test for most gliders to pass. This test is designed to simulate the loading that a glider would experience after 180 degrees of nose-down rotation in a tumbling situation. The glider in this case is mounted tail down 30 degrees, tail forward, and the required ultimate load test speed is 32 miles an hour. Again, the tape is placed at the required ultimate speed on the dial, and the glider has attained that speed at this point. After attaining the ultimate required speed of 32 miles an hour, we continue to accelerate. You see the needle appearing behind the tape, and the glider has now attained a speed of 40 miles per hour. This speed is faster than any speed we've ever run this test to with any glider in the past. The glider went to 40 miles an hour, did not suffer any structural failure. Beyond that, did not suffer any permanent deformation of any of the frame members. Once again, this is the same frame that is presently being used in one of our sport demos. The final test in the certification requirements is a series of tests of the glider's pitching moment. The glider is mounted on a pivot at the pilot tether point, and pitch tests are run at several speeds. The LCD readout on the control bar base tube shows the angle at which the glider is presently mounted on the vehicle. The airspeed indicator on the right shows the speed, and the spring scale on the left shows the force. As the angle of attack is reduced as the base tube is pulled back, the force climbs quickly below zero angle of attack as the bridles engage and the sail reflexes sharply. There are minimum requirements for the pitch-up tendency at angles of attack in the region of zero lift. In the case of the 167 Sport, the pitch-up forces below zero lift are far in excess of the required values. In the 30 mile per hour test, very shortly below zero lift, the spring scale went totally off the scale at more than 100 pounds of force pulling forward on the control bar.